Breault is pleased to announce the ASAP 2009 release. New features and enhancements in ASAP 2009 make this the most feature-rich ASAP release ever. Use the new Conformal Radiometry feature to visualize distributions of light and perform radiometric calculations on any number of planar or non-planar system objects involved in a ray trace. And use transparent detectors as non-invasive probes to monitor light at multiple locations in your system. No longer will you need to pull out your ruler and calculator to take data points from paper graphs. Use the Breault Digitizer to import data from images in bitmap, GIF, JPEG, PNG, and WMF format, and use a flexible toolset for extracting numerical data from various curve types with context-sensitive output for select ASAP commands, including those commands for defining media, coatings, and apodizations. Characterize liquid crystal materials using the new liquid crystal cell command. This highly flexible command, in its simplest form, can describe a linearly varying orientation. For more complex systems, use tables or mathematical expressions to describe director orientation and model a wide range of commercially important liquid crystal systems. Use the new general uniaxial medium to define uniaxial materials by physical thickness rather than optical thickness, and with optional reflectance specified using plane of incidence polarization states rather than device eigenmodes, useful for film modeling where optical thickness is not strictly controlled or where fractional wave retardance variations are not of concern. Use the Stokes-vector mode for polarization to simulate many new system types and track polarization information. Explore partial polarization without the need for ensemble averaging to represent partially polarized states. Use the Poincare sphere visualization tool to analyze polarization characteristics, including the degree of polarization. In concert with the capability to represent polarization using a Stokes-vector formalism, use the Mueller polarization device to describe elements that alter the polarization state and degree of polarization. This provides a path from polarized to unpolarized light that makes modeling depolarizing elements easier than ever. Utilize the new Stokes-vector mode and Mueller polarization device to examine the effects of polarization recycling in backlight display units. Display models may now include diffuse surfaces, hybrid polarizers, unidirectional depolarizers, and polarization analyzers for examining output irradiance, extinction profile, and quality of output polarization. Use the enhanced optimization process to define contiguous blocks of variables, objectives, and constraints with quick multi-row selections in the ASAP script editor, and use text-based optimization state files to save, review, and later resume optimizations in progress. Quickly return to the last optimization cycle completed by importing settings and run data from a saved OSF file. Use the enhanced remote feature to perform true distributed processing with the full computing power of dozens or possibly hundreds of available machines. Initialize and perform distributed processing tasks by licensing remote sessions in a variety of bundles ranging from 1 to 100 sessions. Use the enhanced remote user interface to control tasking of available computers, processors, and cores, and retrieve data from remote sessions. Together, these enhancements set a new standard for optical software capabilities available to engineers and designers. Contact us today to learn more.